Hello and welcome to Lessons from 3 Smart Utilities, a WWT webinar in partnership with Suez Smart Solutions. I'm Liz Berry, contributing editor, and I'd like to welcome all of you to our webinar today. Thank you for dialing in. We have a great lineup of speakers for you this morning. They'll be sharing insights from their own experiences of making the transformation to a digital water utility. We'll hear from Simon Bunn, Senior Manager and Business Development Specialist at Suez Smart Solutions. Simon will introduce our topic and set the context for this webinar. He'll be followed by David Walsh, Regional Control Centre Manager at Northumbrian Water. We'll then hear from Mike Sumbler, Water Supply and Energy Manager at Bristol Water. And last but not least, Bray, Production Planning Engineer, will share the experience from Essex and Suffolk. Our goal is to run through the presentations in around 40 minutes, giving us a clear 20 minutes for audience Q&A. I know there are a lot of you out there in the audience today, so please do type in your questions for the panel as they occur to you. They'll be stored up at the end until the last speaker's finished, and then we'll endeavour to answer as many of them as possible. And so it's my great pleasure to introduce Simon Bunn, Senior Manager, Business Development Specialist at Suez Smart Solutions.
Thank you, Liz. Simon Bunn here. I want to thank everyone for joining this presentation, and hopefully you're going to get a lot out of it. I don't want to spend a lot of time talking from my end. I'm sure you want to hear from our 3 guest speakers, but I thought I'd set the context of what we're talking about. And to start, I might actually mention that in the UK, you may have been aware of us as Dissetto Aquadapt, which is what we were called from 2000 until 2015, when Suez acquired Dissetto, and we're now part of Suez Smart Solutions. And that acquisition has allowed us to develop the product a lot more and integrate it into what Suez calls the Aquadvanced suite, but I won't mention too much of that. So what is Aquadvanced Energy? It's an energy optimization system for potable water, and it looks at all aspects of energy. In fact, I should really call it an operations optimizer. It's designed to look from taking the raw water, whether it be from boreholes, rivers, lakes, and the like, the treatment process, including any chemical addition costs and energy costs, but mainly it's focusing on energy, and in that it's mainly focusing on efficiency. So it's trying to work out which pump or combination of pumps to use to maximize energy efficiency in the network. And by that I mean specifically specific energy, which is the kilowatt hours per megalitre of water delivered. It takes into account load shifting, which makes sense when you have time of use tariffs or spot market tariffs, which about 40% of our customers use. It looks at things like the path that water can take around the network, and it looks at demand allocation in the network. So how does it work? It reads live data. So it pulls information from the SCADA and telemetry system, and from that, it predicts water demand for every DMA or every pressure zone or every pump station. However you think of the network is the way it thinks of the network. It then takes that information on demand and passes it through to an optimization engine. And that works out a strategy for every pump, every valve, every variable speed drive in the network in half-hour blocks of time, so 48 periods a day for 2 days. And it works out a schedule working forward on how to operate the system to keep within all constraints of pressure and storage levels, and do this while minimizing the energy and production cost. And finally, it's a fully automated system. It's designed to be end-to-end. So it sends the commands via the SCADA system. It sends set points to variable speed drives, it sends set points to PRVs and PSVs, and it starts and stops pumps. So I'm going to hand over now to Dave Walsh, who will take you through one of the implementations we did first here in the UK.
Hi, my name's David Walsh, and I am the Network Regional Control Centre Manager at Northumbrian Water. I'm going to spend the next 10 minutes or so taking you through Northumbrian Water's experience with the Aquadapt system over the last 13 years. So it's going to be a bit of a quick canter through to do that in 10 minutes, but we'll give it a go. So moving on to this first slide. So we've entitled the presentation "Keeping the Network Honest." And what do we mean by that? So what we originally procured from the Aquadvanced guys from Dissetto was a software system for real-time optimization and control of water production and distribution systems, as Simon's just explained, but there are wider benefits that it has delivered for us. So obviously, why does it keep the network honest? Well, one of the things that it does, obviously, and as Simon's just alluded to, is it optimizes your network. That was the primary driver for us procuring the system. But as part of setting it up and as part of developing the Aquadvanced system within Northumbrian, we had to do a lot of modelling and mapping. So we had to ensure consistent operation. And by developing that a consistent approach, you reduce the human variability in the decision making in the control room. We also managed to explode many old myths about what was operationally possible as a result of bringing the system in. It fundamentally changes the way we operate many parts of the network, and I've got some graphs to show that later on through the presentation. The dashboard gives visibility of pump efficiency in real time, and I'm sure you'll see a dashboard through these presentations. And if we have any incident or plant failure, the controller immediately optimizes the system, and Aquadvanced provides a plan for efficient recovery. So that's kind of sort of the residual benefits, and that sort of came along as part of the development. So as I said earlier, it's taken this journey for us has taken us 13 years. We started in so Aquadvanced was introduced in a modular way. We started small and we built up the information and the system from there. So the first phase for us was the development of simple assessments of potential energy savings on 2 sample standalone systems. What we were trying to do really here is understand the benefit so we could commit the investment. So again, you know, as we go through this journey, you'll see that it wasn't until 2010, 12 that we started. Although we were working with Dissetto all the way through this, it was 2010 to 2012 where we actually started to build a system for implementation. The second phase for us was to, I'm just going to catch up on my presentation, apologies. Sorry, the second phase of us was the detailed online work. I'm sorry, I didn't switch my presentation on by the looks of this. There we are, sorry. The second phase for this is the detailed online assessment for potential for optimization over the whole system. So again, we widened the view from the 2 standalone systems and went broader. We started to develop some complex interconnected models to simulate interactions between sites. And again, this is building up that level of knowledge of your network and building up the level of knowledge of the systems and how things work together. And that gave us a much more reliable assessment of cost savings from tariff management. So obviously you'll all be aware of the energy pricing that we have in the UK, and you can make huge efficiencies on energy through tariff management. Phase 3 for us was getting into the implementation. So we built full-scale real-time models of the whole NWL network, and I will explain that in a little while. The online links to SCADA and outstations were worked through and established. So within NWG, the SCADA system controls all of the operation of the pumps and the valves and things like that. And there is a link through the firewall to the Aquadvanced system. So basically the SCADA system has control of the instruction for change, and will not allow things that could compromise the performance of the network. So, you know, for example, stopping or starting the 2 pumps together and things like that. And then we established our automated control of pumps and control valves. The little diagram on the left just basically details the journey from the place in the EU Journal Advert Notice in February 2010, and it shows the modular approach where we started work in August 2010. We then delivered the first system in August 2011 into our Teesside system. Then in November we delivered into Essex, and we rolled out from there. So that's that one. So at the moment where we're sitting today, the software is working very well across 4 of our operational areas. So a little bit of background about NWG. You can see on the map on the right, we're an unusual model for a water company in the respect that we have Northumbrian Water Limited in the northeast, and then Essex and Suffolk in the southeast of the UK. We serve about 4.5 million customers across those 3 regions, and we produce about and move about 1,100 million litres of water a day. So the enabling works that we needed to, again, it links back to what Simon said earlier, we had to look at getting remote control of flow meters, pump controls, remotely operated control valves. So there was a lot of that enabling work that needed to be done up front. And then the other thing that was interesting with this is that the cultural issues that we had to work through for successful implementation. So this initiative came out of the regional control centres, and one of the most difficult aspects for us was trying to convince water supply teams to relinquish a bit of control and actually follow the Aquadapt prediction and follow the Aquadapt model. So the stakeholder engagement had to be extensive, and it had to be done over a reasonably long period of time with us going in to revisit treatment teams and asking them to, you know, and convincing them on the merits of the system. But the way that the analogy I would use for this really is it's like the cars that park themselves, and it's asking the treatment works guys to take their hands off the wheel and allow the car to park itself for the first time. So really you have to take them on that journey with you. So basically, as I said earlier, this is a regional control centre initiative, and it did change how we operated. So the guys in the regional control centre became supervisors of the network rather than controllers as such. You can see underneath what was delivered initially across our regions were control of 23 water treatment works and 5 treatment works in Essex and Suffolk. The reason I've put the NWG total assets next to that, if you look at the water treatment works in Northumbrian and Essex and Suffolk, we didn't get control of them all because we didn't need to get the full benefit. It's a bit like the 80-20 rule. So if you get your significant assets in Aquadapt control, you will get, if you get 20% of the big assets in control, you get 80% of the benefit. So you know, but if you look at the number of assets that we now have in Aquadapt control, if you're the controller sat at the desk, you cannot optimize that many assets in one go. The way that we've described it in the past is, you know, if you're sitting, you will look at, as a controller, you will look at the treatment works and the first couple of reservoirs from that treatment works, whereas Aquadapt will look at a full system of treatment works and 30 reservoirs and optimize across that whole system. So that's kind of, you know, that's the way that we've approached this. And as I said, we haven't stood still with this. This system came into play in Northumbrian in 2010, 11, and 12. But as part of business as usual, every time we bring a new asset online, we will have the discussion and the debate whether we can put it into Aquadapt, whether we can have better control. So we're always looking for the opportunities. Now we've got the software with us. We're also using it to do some water quality driven initiatives. So pipeline conditioning is inducing flows in strategic mains to basically keep them clean. And we have 29 automatic operations across our network to do that in place at the moment. So what did it give us? Here's just a few graphs on the immediate difference in operation and benefits that we saw. So this is around tariff. The first set of graphs around the tariff management and pump efficiency. So if you follow if you can see my mouse on the screen, the red line is before Aquadapt, the blue line is after Aquadapt. So the daily flow profile, we are looking to fill reservoirs at when the pumping rate is cheaper, and then we're pumping less when energy becomes more expensive. The second one, you can see the cost, the cost of power. Again, this is about selecting the right machine, the most efficient machine. This is about pumping at the right times when the tariffs are cheaper. We also are using less units before and after, and the unit cost has gone down per megalitre. So that's a really good visual representation of what we've seen and the benefit that we've seen. And And then this just basically indicates using cheapest source on a couple of pumping stations on one system. So what we've done is we've obviously reduced the amount of flow on one of the stations, which is more expensive, and made up that additional flow from a different pumping station that is less expensive. So as you can see, over that period, there was about there was a £7,000 a year saving by changing the route that we pump from. And the financial benefits very quickly, we expected a 7 to 8% saving across the business. As you can see, in the first 3 years in Essex, we actually exceeded our expected savings, which is a really good result. NWL, I think we were lagging behind a little bit because the network is probably a little bit more complex. We were struggling to try and take the asset owners with us, so there was a lot of stakeholder work to do. We've since met that target, but just as a headline, we did remove 1 million units of electricity consumption from NW in the first 6 years. And just to summarize this, just to finish off, basically you never stop working with the system. So we get daily reports from the Suez guys, which we are looking at. We are constantly looking as a team for improvements and enhancements in control. We have monthly meetings with the Suez guys and use the support contract quite extensively, which pays dividend for us. And as I said on there, the support service is effective and it's necessary to continuously improve what you do. Obviously, because the regulatory environment changes, the ODIs change, you have different pressures and you have to respond and react to that. As I said earlier, stakeholder engagement outside of the control room is key to maximising the success, from both an optimisation and a quality perspective. Control room staff need training in the operation with and without the system to maintain competency. So we have a number of our operators now who only know the world with Aquadvanced in it. But again, one of the things that we need to do is we need to make sure that a couple of times a year we switch the system off, and then that gives them an overview of how to operate the system without the support, which also then helps us in our continuous improvement conversations with them and help us with the development of the system. The next point really is it has to be designed with water company input to ensure it works to your constraints. We did some very extensive HAZOPs with the Suez guys at the start of this, and the input from the control room guys and the knowledgeable people across the network and across the supply sites were absolutely essential for us to be successful in this. And the last point I want to leave you with, for me, is it's as relevant to the successful operation of the control room in NWG today as it was when it was introduced in 2011, and I think that's testament to it for us. So that's it from me. My job now is to hand you guys on to Mike Sumbler, who's the water supply and energy manager for Bristol Water.
Thank you, David. Very, very enlightening. Hi everybody. My name is Mike Sumbler. I'm the water supply energy manager and energy manager at BW. My role focuses on short, long-term resource planning, compliance and investment of water assets, and also energy use tracking, benefits, energy saving initiatives and projects. So what I was going to talk to you today about was the project we've just been implementing with Suez over the last AMP for implementation of a whole network pump scheduling system. So as a brief introduction to Bristol Water, so we deliver on average around 280 megalitres per day and up to 360 megalitres per day at peak. Our raw water is supplied from the Mendip Hills in the south, Sharpness Canal in the north, and with a kind of spattering of smaller groundwater sites in between. We've got 16 treatment works, ranging in design capacity from less than 2 up to 165. And we've got an overall energy consumption per year of around 80 gigawatt hours. Our network is relatively small, but it was and remains to be highly integrated and already prior to the project quite an automated system, but it made it ideal for rollout of a whole network pump scheduling system. So the project, the roadmap to network optimization for us, it really spanned the AMP, and like many of us in the industry, we're constantly looking at ways and means of saving on OPEX, especially in the current environment. So early in the AMP, we were looking at various initiatives, energy included, and it was agreed that automated pump scheduling system would be taken forward. Shortly after that, we were engaging various suppliers and reviewing various benefits assessments, site eligibility, and thankfully, yeah, we awarded the contract to Suez. And then moving on to the following year, refining some of that benefits assessment and bolstering the business case and confirming which sites we would like to roll the system out onto. 2018-19, it started to get even more serious. So we spent a lot of time focused on system parameterization. So there was quite a comprehensive pump testing process where we tested at least 180 pumps across 70 odd sites. And then commencing with the ICA, IT, and final model design with a small pilot test at one of our sites, just to give us a little bit more confidence going forward. So most excitingly, and about a year after I joined BW, we started project implementation. So that was when we started seeing some of the first look at the system, communications tests, and rolling it out on a subsystem basis. And I'm going to show you and talk a little bit more about that now. And then finally, where we are at present is looking at people change, training, improvement, enhancement of the system, and the all crucial benefits and performance tracking part. So yeah, implementation of the system. So after several years of building up the business case and working through the numbers, user acceptance testing and training was the first time we kind of had a good look at the system, and we were able, even then in an offline mode, to start finding the snags in the system and resolving some of the issues with the proposed configuration. But then it really took underway when we started a quite intense period of ICA work, instrumentation control and automation work. So that was programming the PLCs to receive commands from our remote SCADA system, Prism, Scopex, whatever you may use, to make sure at least from that part of the system that was receiving and being handled correctly on site. After that, there was another quite intense period of 10 weeks of seeing the system AAE pass through commands, schedules right through to site PLC level, and also reviewing the individual pump schedules and making those final parameter checks. So following that period, sort of October through to January, really, we started rolling out the system subsystem by subsystem at a time. By subsystem, I mean the more integrated parts of the network, sort of starting in the south and slowly working our way west and north, really. So finally, the system now, at any one time, it comprises, it controls up to 180 pumps across 72 sites, both potable and raw, with 17 major valves in between. So moving forward to where we are, so implementation as a project is largely come to an end, and now it's kind of very much my role and the energy team to work with the rest of the business to move it in to business as usual. And we've badged the whole system, really, and the whole system, I mean that AAE is seen as very much and all pump scheduling systems as a fourth tier of control. It's doing a whole network optimization every 30 minutes and passing out those commands to the traditional telemetry and SCADA system. So tier 3 would be your remote control system, your Prisms, your Scopexes, and tier 2 is your local PLC, slightly more isolated systems. Now, the reason why this needs to be considered as a whole system, is that AE sits on the top, but to maintain safe operation, you need to have the system that can fall back at any one individual site at any one time if the system goes outside of parameter. So that's really important to us, staying safe. And the other, which David's talked quite a lot about, is engaging staff and stakeholders. So people, process change, development, proceduralization of everything that is Ipsos is now quite a big piece of work, and actually has lots of other fringe benefits to us. System improvements. So we now have a whole network optimizer. We've gone through some detailed design in the project, but of course there's still sites that we'd like to include. There are still improvements that we're making whilst we're seeing the system over a full 12-month period in operation. So seeing both summer and winter operating conditions, and how we carve the system to cope with those changes. And finally, developing a reasonable amount of work as well to develop a robust method of quantifying the benefits, that in a way so that they're indisputable. So kind of to round it up from me, really, there's been a kind of series of challenges and successes. So I would say for anyone embarking, any other companies embarking on this project from a clean slate, you'll find, as you would imagine, and as David mentioned again, the success of the system requires operational staff and all other stakeholders be fully engaged, especially the control room. So the project team, including myself, were pretty much embedded within that control room for the entire project, and still now maintaining very, very close ties. The second challenge would be shared resources. So in various companies I've seen, the ICA teams are usually in high demand. So it's critical that to delivery of a project like this, that they're fully resourced, and there's a recognition from within the company that this is a project that needs prioritizing. And then the technical issues, so level control, where the forecast levels are going outside of, the actual levels are going outside of forecast. It's making sure that we work with the control room to really hammer down what the control levels should be, and making sure that when it is outside of a forecast, that all controls are in place to then also re-establish selection and control. Communication, so we have quite a rural patch. We've got some sites which do drop out now and again when the heartbeat is not being received. So it's again working with the ops teams to make sure, particularly control rooms, to make sure that sites are brought back into control in a timely way. Conflicting existing or historic PLC controls, so very much like many PLCs, they've got layers and layers of programming in, some historic, some redundant, but we have found that some of that redundancy is sometimes conflicted with the way we want to operate the system, especially as we're pushing the system into different ways of operating. So in those cases, we've had to go out with the PLC, get more of the ICA team's time and do a deeper decode and recode. And the final one, we did a lot of work, like David as well, around HAZOP, quantifying the system, parameterizing it. But in the end, when you actually start to implement the system, you start finding, well, actually these parameters need to be changed, amended to, and who knows this, and gathering that information as you go as well, to think that you'd have a perfect design from the outset is probably a bit naive, perhaps. So those things are all easily resolvable, and it just takes a lot of drive and hard work to resolve. So but the success is for us, it's been a rapid sort of network-wide rollout, and the first thing that would have caused us concern early on the project is that safe to do. And again, coming back to IMSOS and the tiers of control, we've had no problems. It's been safe, and those standard controls have remained in place and safeguarded supply to our customers. The other fringe benefit, which certainly as a smaller company have found, is that learning more about our own system sort of picking up that unwritten tacit knowledge which sits in people's heads across the business has been a really high value and continues to benefit other projects within asset management. So, and then finally, the hard benefits, the benefits which everyone wants to see come to fruition. Under our current estimates, we're seeing about 15 to 20k savings a month, and that's set to grow as time goes on to 30 or 40. So to conclude, I guess in a few words, we're good with planning and some hard work implementing a system such as this. I would say that it is safe and it saves. And I think that's it for me. I'm going to pass over to Bernard Bray from Essex and Suffolk. Thank you very much.
Thank you very much, Mike. Your story really reminds me of what we went through 10 or 12 years ago. It is a journey that you've embarked upon, and I'm sure it will be successful. So for me, I have a couple of topics that I'm going to touch upon today. One of them is the cost savings analysis, and the second one is water quality blending. So off we go. So I'm going to use a pumping station within the Essex network as the example for this. So the pumping station is a site called Wood and Walter, and typically it's, well, not typically, it houses 3 750 kilowatt pumps, duty, assist and standby. It boosts water in our network anything from 90 to 200 megalitres a day. When the flows in this part of the network are greater than 90, then the booster station is required for hydraulic management within the network. We have 2 upstream pumping stations that feed in series into this particular pumping station. So it provides a way of managing the hydraulic gradients through our pipelines. Before Aquadvanced, we did not do any energy optimization at all in this part of the world. Operation was based upon controllers' historic knowledge, historic operations, and those individuals had very little understanding of hydraulics and optimization. So the cost savings side of things tends to be a bit of a conundrum in how to go about understanding what you used to do and comparing it with how Aquadvanced operates the system. So for the first point, we took 2 years worth of data prior to switching on Aquadvanced. So 2 years worth of flow data broken down into 30-minute chunks. We appended the kilowatt hours for those 30 minutes, so we know what volume of electricity we had consumed. We compared that to the energy tariff for those periods. The energy tariff, of course, is quite a complex thing in the sense that it has seasonal variations, weekday, weekends. So that all needs to be applied to the data to get a true pounds per megalitre number. Once we have that bit of information, we then need to make sure that we compare apples with apples. So the way we did this was we looked at banding the volume of water that we transferred through this pumping station in any given day. The bands were broken down into plus or minus 2.5 megalitres either side of a median. Once we did that, we were then in a position to be able to calculate the average cost per volume band. Once we've done that, once we go live with Aquadvanced, we do exactly the same calculation again post Aquadvanced. And the difference between the pre and post for each band gives us an indication of the savings. And for this pumping station, this was the outcome. So on the x-axis, we're looking at the banding. So W100, for example, would be 97.5 megalitres to 102.5 megalitres volume in a day, and the y-axis is the pounds per megalitre. So as you can see, prior to Aquadapt, we were consuming energy at a much higher rate per megalitre than we were post. I've left on the left-hand side of this graph as an interesting aside, because historically we were just manually running this site. There was never any discipline from our local controllers to switch anything off. So what we see for flows below 95, volumes below 90, 95, 85, what we see is controllers were probably running the pumping station when they didn't need to. And what we see from an post Aquadapt, we see that Aquadapt uses the pumping station infrequently during those periods. And almost certainly the costs that we are incurring are costs that we incur in the middle of the night when our energy costs are cheaper, and we're transferring a greater volume through those periods of time. So a natural question to ask at this point is, well, what does that mean in cash terms? So this slide shows the summary of that analysis. So for this pumping station alone, we were looking at somewhere in the region of £100,000 per annum post Aquadapt, which is a nice saving to have. I'm now going to move on to my second topic, so there'll be room for question and answers at the very end when Liz takes over. So the next part of my talk is about the water quality blending. So once we'd got our optimization working from an energy point of view, it almost seemed a natural progression to use optimization theory and considerations to attack water quality blending issues. So for this particular subject, I've picked Langford Water Treatment Works. It sits on the confluence of two rivers, so it's river water that we're treating, albeit we do have a storage reservoir that buffers between the rivers, but it holds about 3 to 4 days worth of water. During particular times of the year, we suffer from chemical pollution in the river. We have probably between October and December, we have metaldehyde that we have to manage, and from sort of December onwards through to possibly even March, April, we have high nitrates in the rivers. From a blending point of view, and the way we handle those chemicals are both exactly the same. So in the presentation, I refer to nitrate, but I could easily substitute the word metaldehyde for nitrate, and it's exactly the same process. So we abstract river water into a bankside storage, and we've attacked the nitrate blending in two specific ways. The first is we attack it on the raw water abstraction out of the rivers, and the second and most recent innovation is that we also address high nitrates coming out of the treatment works by blending with low nitrate treated water in the final water. We do this by, we have a laboratory analysis carried out for the three main protagonists: the rivers, the treated water, the treated water, blend water, the final water coming out of the reservoir. And we use these values to calculate the mass balance required. And this is done in the Aquadapt world. Aquadapt takes these concentrations that we input onto our SCADA system, and it uses its optimization capabilities to abstract water out of each river, but maintain the chemical concentrations below a prescribed amount in the raw water reservoir. We can only do this for so far, because inevitably, generally speaking, particularly when nitrates are involved, the levels do become above the maximum constraints that we're allowed for to enter into the public water supply. So when we have that situation presented to us, we have two choices. we either take the treatment works offline altogether. Sometimes that's the preferable option, but more often of late, we've tended to keep the treatment works in operation, and we blend the low nitrate treated water from another source with the final water of the output of the Langford treatment works. We do this in a slightly different way. In the SCADA system, we take the laboratory results and we calculate a blend ratio. And that ratio is used in the Aquadapt world in order to set the minimum constraints for our blend water. There is an upper constraint, but that's set at our maximum hydraulic limitations for no other reason. So what this gives us is a minimum constraint for our blend source that Aquadapt must obey. That minimum is applied to the blend valve that we use to do the blending with. We're then free, or Aquadapt is then free to actually use more blend water if there is a financial incentive to do so. And I expect that to be the case. We haven't commissioned this in anger at the COVID outbreak has put a bit of a delay on some of the commissioning. But with my experience of optimization, I'm expecting Aquadapt to use this blend water as a routine, not as a specific action just for nitrates or for metaldehyde. And I think that finishes me. So I'm going to hand back to Liz for the Q&A.
Thank you, Bernard, and thank you to all of you. That's fantastic, very rich set of presentations there. We now have a Q&A session. We've had a number of questions coming through. Simon, there's one that has come through from one of our audience, and they are asking, how did the systems perform during recent demand increases around the end of May and the impact of COVID-19? And I know that we had spoken about this and you had a slide you wanted to share, and perhaps to talk through how that had worked.
Yes, thanks, Liz. I'm obviously, if you can give me the screen, I'll show that slide. It was interesting that during COVID, of course, we saw a significant impact on demand, and I'm showing you a screen here from Boise, Idaho, which is one of our customers. And what I'm trying to show you here is the typical demand profile that we'd expect during a Thursday and Friday during the normal operations, where we have a tool which we call PrevAqua, and PrevAqua is a machine learning tool. And so that there is predicting demand, and as you can see, it's tracking very, very closely on its prediction to actual demand. But as soon as COVID came in, we saw a big noticeable change, and these green and orange curves down the bottom are exactly the same zone on exactly the same Thursday and Fridays, only about 2 or 3 weeks later, and you can see this massive change in demand. So it dropped dramatically, moved in time because obviously people were getting up later, held on during the day, and dropped at different times. Now, if we had had some sort of standardized profile for demand, we'd have been in trouble. We would have been missed predictions. We would have overflown reservoirs possibly. We might have had to shut down treatment works. But because we are running machine learning, which is adjusting in real time, Aquadvanced just picked up the change in trends and used its own new predictions. What we have seen at places like Milan, for example, which we've been operating in, we were there at the time Milan was hit with the COVID crisis, and I had a team up there. They had a similar reaction. They had a very sudden change in demand. But now that Italy's pulling out of the COVID crisis, it has gone back to a more normal pattern. And what they've told me anecdotally is that the operators really didn't have to do anything. The Aquadvanced picked up the changes and adapted, And although they were running around and in some cases having a real struggle getting staff in to operate the system, they were very thankful they had an automated system in the background, because it removed the stress of trying to cope with these sort of changes, which they had never seen before, and therefore they had no operational strategy for. So hopefully that answers the question.
Fantastic, thank you very much, Simon. We have had another question, which is quite a broad question. So I don't know if members of the panel want to kind of jump in on this. It's asking, it says, Northumbrian have been on this smart grid network optimization journey for many years, which seems pioneering and progressive. Do the panel feel there is an increasing trend for broad adaptation of this? So perhaps, David, if you want to take that one first.
Yeah. So what do they mean? Adapting the Aquadvanced software, or the approach, or?
They mean adoption. So do you think that this there's a trend in the industry for companies to more broadly begin to adopt the approach of network optimization?
I mean, speaking from personal experience, the number of companies that have come to visit us, and UK companies that have come to visit us just to actually see what we're doing and see how we control the network, has been extensive over a number of years. We managed to run our network, the Essex, Suffolk, and the North East, with 3 operators, 3 control men. And again, that one of the reasons that we can do that, I think, is because we have the automation, and because we have the software available to us. So I think there is a push, there is an appetite for it. And obviously, the likes of Bristol have taken the step and made the change. So yes, I do think so. I don't know if Bernard wants to add anything, because Bernard was with us at the start of our journey within the Northumbrian. I'll go into it later on. I don't know if you want to add to that, Bernard.
Yes, so the Essex experience, we were doing a very little bit of optimization prior to Aquadapt, but it was crude in the sense that maybe we were just avoiding peak periods and pumping hard at night, which, when you start calculating and understanding optimization, you generally find that actually is not the recipe for success. It's part of the journey, but it's a blend between sometimes you need to pump at peak times and sometimes you don't. But to sort of address the question that you put forward, it has been a journey that we've been on for quite some time. It was a natural progression for us to build upon the knowledge that we had in the business and the understanding of optimization, and realize that what we were doing didn't fulfill the need. It had no automation, it had no SCADA automatic control of plant. And when we first were introduced to Simon, when it was under the Desetto umbrella, to me, it ticked every box immediately that this was definitely the next step that we needed to take.
Okay, fantastic, thank you. Another sort of related question. Sorry, did you want to come in, Mike?
Yeah, I was just going to comment. I joined Bristol in 2018, having just come from Essex Water, and they also were implementing a similar system, and their directive really was to provide a better form of control, relying simply on local controls, PLCs, was insufficient to push water across quite a large part of their new scheme, designed to offset quite severe license reductions in some of their patches. They needed a system that could do whole system optimization at once. But they were also, again, they were focused on energy, just as Bristol is. So, but Bristol very much driven a focus on reducing energy use. Looking forward to net carbon zero and those initiatives, and also in an energy market at the moment where it's quite volatile. We're certainly seeing some big heights in costs, particularly commodity costs. It's a system that just makes sense, and being a bit later to the game than maybe Essex and Suffolk, I guess some of our systems, control systems, that had already matured enough to bring it in. So we didn't necessarily have to go through some of those enabling works which Essex and Suffolk did back in the earlier years. So yeah, I would say it is becoming and should become widely adopted for many reasons.
Yeah, okay, great. That's interesting. A sort of slightly different perspective given where you were at in your own evolution as a utility. Okay, great. Related questions come in. Do you include DNO charges in your energy tariff calculations, or just the supply costs?
I can answer that one. So the energy tariffs can be incredibly complex, and we have systems that are demand charge only. They have time of use. They can be flat but with a demand charge. They can have a coincident maximum demand charge, which means it only applies during a window of the day. We have systems that have a combination of all of those. We've also worked with Northumbrian on triad and store projects. In the United States, we worked with what's called PLC, which is peak load contribution. So all of the aspects of the energy charge are taken into account, and they have to be, because obviously we're trying to minimize cost. So if we don't understand the tariff structure, we can't minimize that cost. I think Bernard also picked up something that sometimes what seems obvious, like don't pump during the peak period, is not actually the right answer. What we have found, for example, is that most of the savings come from efficiency improvements. It's not necessarily load shifting, it is actually pumping with the least amount of energy to get the water to where you would need it to be. And that's a combination of hydraulics, pump curve, system curve, demand prediction.
Okay, useful. Okay, thanks very much. There's another question, and it's related to the support contracts, which I thought was quite an interesting angle. Is to understand that once software is implemented would lead to energy savings. We'd like to have feedback from the utility presenters as to how was the support from Suez as a company while they were implementing the software. So perhaps I'll go to Mike on that one.
Yeah, we had a really good experience. The guys from Suez were pretty much embedded into Bristol Water, like it or not, for a good 6 to 7 months. Became quite good friends with some of them. So the support and the professionalism was always there. Any time of the day, given that equally the time zone differences and being staffed in New Zealand and in the UK, it's gone really well. And just to kind of quantify that, perhaps moving away into BAU now, we're having a weekly conferencing with the New Zealand office and some of the experts there, and have constant communication during the week as we deal with some of the further parameterizations and improvements on the system. So yeah, it's been really good.
Great, thank you.
I think I would like to just add a little bit there too. From what Mike said, again, it's exactly the same experience that we had in Northumbrian. The professionalism and support from the Dissetto guys is fantastic. But you do need that, because whilst you think you have a good understanding of your network and you think you've got great kit that's going to work first time, the reality is you'll spend the next year improving it beyond anything that you thought was possible. Everybody learns a huge amount, and there's always things that you need to do differently as you travel that journey in the first year of switching it on. And you need to have your hand held by the engineers of Dissetto.
Great, okay, good, thank you. Good to hear about such positive experiences. A question, Bernard, for you specifically, and your presentation. It asks, do you have to do more regular verification of flows that the blend ratio is calculated from? I'm guessing that was relating to one of your specific slides.
Yeah, obviously the flow metering side of it is important, and we do have a 2-yearly flow verification validation contract with an external agency who looks at our flow meters. So I think we have that covered.
Great, thank you. There's another couple of more technical questions. I think these probably ones for you, Simon. It says, may I please ask about computation? Are you using a hydraulic model based approach? And if yes, what is your take on an approach based on simple system curves with no hydraulic model? And then the second part is, you mentioned 2 days forecast. We have more like 7 days base cycle. Do you think that the software could deal with that?
Two questions that come up quite often, actually. So taking the first one, we do use a hydraulic model, but not actually as part of the optimization. So we have an embedded model of the network because it's a holistic solver, and that has pump curves in it, and it's because it's trying to calculate kilowatt hours per megaliter delivered. It's working out what it thinks is going to be the system curve and the response, and where the pumps are operating on the curve. So, but for speed, and we're talking about running this on a standard computer, or a reasonably standard computer, we run our internal model. Once we've finished that, we pass it to the digital twin, which is the EPANet model. And the EPANet model is better, no doubt, at calculating what the impact would be over the next 24 or 48 hours in the extended period simulation based on what we're going to give it in terms of pumps on, off times, variable speed flows, and so on. We take that information back, we compare it with our results, and if we see that we have to review or change anything, which is usually a system curve operating point change, we will run through the optimization again. Now, we do that twice sometimes we do it 3 times, never more than 3. And that's, so you're getting the best of both worlds. But we also have a simpler tool, which we call Aquadvanced Energy Tier 2, which does not have an embedded hydraulic model, and that's obviously just to reduce cost. You do lose a fair bit in the efficiency savings I talked about earlier. It is possible to do it, and obviously we do it, but if you're a reasonably large user of power, it is worth chasing the efficiency savings. And then on the second question you had, what you should really think of is that Aquadvanced Energy is about right now. What should I do right now? I know what my storage tank levels are. I know what my future demand is going to be. What should I do about bringing pumps on or taking pumps off, using my storage as well as I can, taking into account the time of the use tariff over a day, and it is repetitive over a day. However, a lot of our utilities have 7-day tariffs where the weekends are cheaper, and we do take that into account. So we actually have the ability to set some of the things through what we call the target cycler. It's not a true 7-day solver, and we have considered extending through the solution to 7 days. We solve in 2 parts. One is what we call continuous, which means we look at basically the flows we have to generate through the system, and we could do that over 7 days reasonably easily. And the second part is what we call discrete, which is which physical pumps we're going to start and stop to achieve those flows, which we could actually maintain just on the 1 or 2 day boundary. So it is something we are looking at, and I think it will actually happen.
Okay, great, thank you. Sounds very comprehensive. A further question has come in. I'm not exactly sure who best to direct it to, but perhaps you'd like to jump in. How often are the hydraulic models calibrated?
I can answer that as well. I mean, one of the things that Bernard and Mike and David told you is that we obviously are monitoring and supporting the system, and we get a daily email report, which everyone here gets as well. And the daily email report has a lot of graphs on it, and those graphs tell us the accuracy of the hydraulic model. They can tell us how accurately we're predicting flows, pressures, and levels. If we see a divergence at a specific point, it's usually because a valve has been closed in the field or something else has happened, and sometimes that's just maintenance. However, if we see drift, and we do see it, then it is worth recalibrating the hydraulic model. But in general, we only need to do that once every couple of years. But there'll be enough changes in the network that we're going to probably be adding new elements in the hydraulic model anyway for new pipes and new pumps and new tanks and so on. But for a general model review, probably every 2 years is more than enough.
Great, thank you. Another question also on the hydraulic model. This is obviously a hot topic. Could you quantify the extra efficiency saving achieved by going the extra miles?
We have been very, very consistent on this. So we monitor it everywhere, and it's been between 6% and 8% in almost every time we've looked at it. So that is the reduction in kilowatt hours per megalitre. And that graph that Dave Walsh showed you with a chart which showed kilowatt hours per megalitre, do you see the difference between those two levels? It was 8%. So it has been very, very consistent.
Fantastic, thank you. There's another sort of more generalised question. I think it's quite an interesting one in the context, and perhaps a nice one to close with. It's asking, you know, stating this is advanced and innovative stuff. Do you feel that the criticisms that the water industry is not innovative enough are unfair? And perhaps I could take each of you in turn. Maybe Dave, you'd like to kick off with that one.
I think it is unfair, to be honest. I mean, within the Northumbrian Water Group, we run an innovation festival, which is going into its third or fourth year, where we bring people from all over the world and you know, and are trying to deal with a lot of the hot topics and issues across the industry in a more creative and innovative way. You know, as I said, you know, within the regional control centre, we've centres in Essex and Suffolk and the North. We are constantly looking for better ways to do things. I think where it becomes more difficult, obviously, is we're all fighting for a relatively small pot of money. But I think there's a lot of creative people and a lot of creative thinking done within the industry around, you know, to resolve some of the issues we have.
Great, thank you. Mike,
Yeah,
I was wholeheartedly agree with David. Yeah, and innovation is a big word. It's not just about reducing operating costs. It's not just about operations, really. So, you know, I'm in a kind of asset management team, water resources, environment, catchment. The whole outlook and the whole impact a company like ours has on our customers and the environment is one we are striving to challenge dogma and innovate in all the time. There's a big body of people in every company working on that, and this is one part of it.
Fantastic. But Bernard, from your side, how do you?
I think there is a considerable amount of innovation within the water industry, but as Dave touched upon, it is the financial side of it that causes the biggest problem. So I think if Simon remembers, I suspect we started this journey maybe 6 years before we implemented. We went through an awful lot of pain within our own company to jump over hurdles to try and justify what was, whether even in day one, was an obvious benefit, and we didn't grasp the net. I think partly probably because we're risk averse is one of the big issues we have within the water industry. We might be innovative and we might like to think we're innovative, but we're not great risk takers.
And I think just to build on that very quickly, because I'm conscious of the time, but we needed to have the determination and the dogged people involved at the time, and it's very similar to Mike's situation, who were prepared to go on that journey to get us to the right place. And I think that's obviously been key in Bristol. It was key within the Northumbrian Water Group as well, to actually just, you know, we knew it was the right thing to go for, and we just kept going and kept going and kept going. And as I said, I mean, I finished my slides off with it's still relevant today as it was in 2011. We're using it we're using it every day. It supports us every day, and it provides, you know, tangible benefits for us.
Yeah, great. Thank you, Dave.
I'll just slightly add on that the whole experience and kind of roadmap doesn't end at the end of the project for us. It's giving us a platform for continued innovation.
Fantastic.
If I could just step in.
Simon, you'd like the last word, yeah.
Yeah, I was just going to say, I mean, your sample speaker panel here are obviously classic examples of innovators. The fact that they've actually been on this journey just demonstrates it. And I think Northumbrian was incredibly innovative to do this when they did, which is quite a few years ago now, well ahead of anyone else in the industry. They were the first in Europe. They did a lot of work. They had already made a lot of steps on the journey, which Bernard's already mentioned. And so for them, it was the next logical step. And I think we were there at the right place, right product at the right time. So, you know, I applaud everyone in the presentation.
Fantastic, thank you so much. So I hope you will all agree that it's been an extremely fruitful session this morning. I've learned a lot, and I hope you'll have too. This webinar will be available on demand from www.online.co.uk, where you can listen again or share the link with your contacts, and you will receive an email with that link. And so it remains for me to extend a huge thank you to you all for dialing in, to our speakers, Simon Bunn, David Walsh, Mike Sumbler and Bernard Bray, and to our sponsor, Suez Smart Solutions.